So I'm going to talk to you today about our experiences with async JavaScript at Netflix. Now, all of us JavaScript programmers have experience with async programming. So first, a little bit about me. I'm the cross-team technical lead for Netflix, so I work across all the various Netflix UIs, the vast majority of which, as Matt mentioned, are written in JavaScript. I got about 13 years in the industry, formerly worked at GE and Microsoft, and I've got about 6 years under my belt doing functional reactive programming, building systems, that is. So this is really the story of how Netflix solved big async problems by thinking differently about events. And so our app, and in fact most JavaScript apps, are very asynchronous, right? We have all these modules with app startup where we're coordinating, waiting for platform components to come up, and we're waiting for things to come back from the web. We have the player in which you can play and then cancel. We have data access going on at all times. We've got animations to coordinate. We've got our view to bind to a model. All these things are asynchronous processes, and they can really, if you don't get them under control, they can really cause your app complexity to just explode. So let's go back, 3 years. Netflix was really sort of struggling with async programming, as I think a lot of us were sort of 3 years ago. At the time, we were really in callback hell. And so callback hell is this challenge of trying to coordinate something complex using callbacks. Now, so this is a sort of a contrived example, but it's not too different than what we had in our player back then. So as you can see in a player, why is async programming so hard? Well, part of it is state. So if I have two callbacks that are both in flight, and I want to wait until they're both finished, well, the only way to do that is to introduce a variable and to sort of track the state of both of those callbacks. And now you find yourself introducing variables and variables to track what's going on, a variable to track if I have my movie ticket yet, or a variable here to track whether my player is initialized. All of a sudden, it can get really difficult to scale an app that way because you add all this state, and that state's got to be maintained and kept in the right, state. And so another issue, one of those big issues with async programming is that when we're doing synchronous programming, try-catch really does a lot for us, right? Try-catch propagates errors, we can catch it up here, but when you go into async programming, try-catch are pretty much useless. And the environment provides us no help whatsoever in sort of managing exceptions. And so how do we get back to that same, smoothness of dealing with exceptions in synchronous programming with async programming? So as you can see here, we just got even more state just to track the state of the errors that we're having. And then finally, whenever you're doing async programming, especially evented programming, there's always the risk of memory leaks. So I've deliberately left a little bug in here in which I subscribe up to a cancel button and then completely forget to unsubscribe from that cancel button. Anybody hit a memory leak like that? They're not too easy to track down, are they? So we have all these problems, and you have race conditions as well, right? As soon as you can do two things at once, it means there's the possibility of a race. So now, how did this happen? How did asynchronous programming get into such a bad state? How did it get so hard? Well, to really answer that question, you got to go back 20 years. So good year, 1994. Speed had just come out, I think. Weezer's Blue album. It was a very good year. Who has read this book before? You've just dated yourself, people. Yeah. Who has the book and it's just sitting on their desk? They haven't read it in a long time. There you go. Yeah. I like that, admitting it. So Design Patterns was a very influential book, written 20 years ago. And what the gang of 4 authors, they tried to do was they took a look at all these design patterns and all these patterns that had developed in the industry for solving common problems. And they said, you know what, let's sit down and let's document these. And it was a very influential book. And today we're just going to focus on they actually had this diagram inside that book at one point. And they really put in an effort to try and take all these patterns and show how they were related to each other. And so you don't have to look too closely at this. Today we're only focusing on 2 of these patterns. These 2 patterns are the iterator and observer pattern. So not every JavaScript programmer is familiar with the iterator pattern, but it turns out that in the next version of JavaScript, JavaScript 6, we're going to get iterators native in JavaScript. So the iterator pattern was really the gang of 4's way of allowing any data structure, any collection, allowing a consumer to sort of pull data from any particular collection, no matter what that collection is. So it could be a list, it could be a set. The iterator was the model was, you ask the data producer, the list or whatever that data structure is, for an iterator, and then you just ask for the next item for that iterator. And you progressively just keep getting items from that iterator until the iterator said, no more data. Right? So that's how iterator worked. But there was also this other pattern, and it was all the way over here. It wasn't even related in their diagram, called the observer pattern. And the observer pattern was really kind of like the same thing, except the difference is, this, by the way, is the precursor to PubSub or event emitter. Who's done work with PubSub, either in Node or, right? Today, it's really about a producer sending data to a consumer, one item at a time, progressively, right? If you think about it, the iterator and the observer pattern aren't really that different. In the iterator pattern, the consumer's in control and it's pulling data one item at a time until finally the iterator says, I'm done. But in the observer pattern, what's now become the modern event emitter, right? You give a callback to a data producer and it calls you again and again until finally and that's where something was left out. They didn't really give the observer pattern, they didn't give the producer a way of saying, I'm done. It's a little bit odd because both these patterns, as I said earlier, they're both about progressively sending information to the consumer. But in the observer pattern, and just in PubSub with event emitter, there's no well-defined way of just saying, you know what, no more data is coming to you. So that was one thing they left off. Well, what if we add this notion to events? The ability for an event to say, you know what, I have no more data coming to you. Well, it turns out that we can approach programming over, synchronous programming over collections, in-memory collections like arrays or sets, in almost the exact same ways we can approach event-based programming. So, as I said, iterator pattern and observer pattern almost the same. The only difference is in the observer pattern, the producer iterates you, right? So, as I said earlier, now I was working at Microsoft about 5 years ago, and I met a man named Eric Meyer, and he asked me a question. He said, what's the difference between an array and an event? And the answer to that question absolutely blew my mind. I was very excited by the technology I'm about to show you, and I was very, very eager to take it to a company like Netflix and sort of build an entire system on it. Now, 2.5 years later, we've really done some amazing things based on this simple concept that events and collections, in-memory collections, are really fundamentally the same thing. So as I say, both collections. But first, now a brief JavaScript 6 tutorial. Who's familiar with what's coming up in JavaScript 6? So I want to say this technology has nothing to do with JavaScript 6. The only reason I'm teaching it to you is for two reasons, actually. One, I'm on the JavaScript 6 committee, and we want people to get excited about JavaScript 6. Two, JavaScript 6 allows you to write a lot less code to do the same thing, and consequently, it allows me to fit a lot more code on slides. So if you'll bear with me for this brief lesson, it'll just take a second. JavaScript 5, this is how you create a function, right? We've all done this. Starting with JavaScript 6, you can get rid of all this boilerplate, and you can do this. I'll pause for applause. Yeah, right? This is great. Great stuff. So the slides just got a lot shorter, as you can imagine. So that's the end of the JavaScript tutorial. You're all JavaScript 6 experts now, all right? So I'm about to show you guys just a few functions. And the truth is the vast majority of Netflix's async code is written using just these few flexible functions. And at first, when I show them to you, they're going to seem to have nothing whatsoever to do with async programming. So bear with me. So the first one, we all know this. This barely even counts, right? We've all done this before. We can for each over an array. You pass for each a callback. It calls you for each item in that array, and then we're done. So if we were to log this to the console, we would see 1, 2, 3. Pretty straightforward, right? We've all done array programming. Next one, map. Quick show of hands. Who's done map? So you know what map is, so I'll speed along here. Take an array, apply a function to every item in the collection, and we generate a new collection containing the translated results. So what am I going to get? Shout it out. 2, 3, 4. Okay, cool. I'll speed along. I can see you guys are quick. So filter, nearly the same as map, except this time that function is going to return a Boolean. That's a test. We're going to apply a test to every single item in the collection and create a new collection with just those items that pass the test. Filter 2, 3. Okay. Now this method does not include, this is not in JavaScript, and it's not going to be in the next version of JavaScript, but you could add it pretty easily. concatAll takes a multi-dimensional collection and flattens it by 1 dimension. So in this case, it's going to take a 2-dimensional collection, flatten it, and we're going to get 1, 2, 3, 4. Right? So quick review, map, filter, concatAll. With these 3 functions, I'm going to show you we can do some pretty amazing things. So we got a lot of Netflix users here, I'm sure, right? This is the new Darwin UI that we've been working on for the last year. I think it's absolutely beautiful. And if you use Netflix, you know that our model is relatively straightforward. It's a list of movies, sometimes affectionately referred to in the company as a LOLAMO. So you have a list, you have genre lists, and then within that, you have titles, right? So why don't we use map, filter, and concatAll to pick your favorite Netflix titles out of your particular LOLAMO, right? How hard can it be? So I'm going to write a function called getTopRatedFilms. And it's going to accept a user object. Remember, arrow means function, people, right? It's going to accept a user object. And I'm going to go through the user's video lists. I'm going to map over them. And for every video list, I'm going to return the videos that have a rating of 5. So before I return the videos, I'm going to filter the videos for only those videos with a rating of 5. Now that's going to leave me with a two-dimensional collection, because for each video list, we are returning another collection of videos, which is filtered. And so at the end of that, I'm just going to apply concatAll to that and flatten it into a nice flat collection of your favorite Netflix titles. And so then I'm going to call my get top-rated films on a user, and then I'm just going to for each over the resulting collection. And that's how we get your favorite Netflix titles. So what would you say if I told you that I could take nearly the same code and I could write a mouse drag event over a DOM element? Hmm?
No way.
No way, thank you. That's what I was waiting for. So here's how you get your top-rated movies collection. I want you to look really carefully because it's going to happen so quickly you might not even notice. Now I'm going to switch over. Here's how you get a mouse drags collection. So let's imagine that instead of add event listener, remove event listener, every single event on a DOM element was a collection. So what is a mouse drag event? Well, given a DOM element, I am going to map over all of the mouse downs in the mouse down collection from here on to eternity. And for each one of those mouse downs, I will return the mouse moves at the document level. Now, in the previous example, I used filter to reduce the items in the collection, to reduce the number of items in the collection. In this case, I'm going to use this new function, which I'll explain in a moment, called TakeUntil. What TakeUntil does is it listens to its source collection, an event, and it listens to a stop collection. And as soon as that stop collection fires an item, the whole event collection is completed. Remember that thing I said was missing from the observer pattern, the ability to say, I'm done, there's nothing more. It completes, and that leaves us with a two-dimensional collection, because for every mouse down, we get a collection of mouse moves that we reduce the number of items of. And so we've got a two-dimensional collection, so we apply concatAll to flatten it out into a nice stream of points that represent where my mouse move is while I'm dragging. And then, what do I do with this collection? I for each over it. When you subscribe up to an event, you are traversing a collection. When you add an event listener, that's all you're doing, traversing a collection. And so I take that position that comes through, and I adjust the image position, and now I'm dragging an image across the screen. Who's got it? Who's a little bit shaky on this, wants a little more information? Okay, let's take a look at how's this possible? A new collection. A new collection we discovered really only 5 years ago. It's called an observable. And an observable is just a collection of items over time. Now, where does this observable come from? It comes from a library called Reactive Extensions. Quick show of hands, who's heard of Reactive Extensions? Okay, so some folks. Reactive Extensions is basically this new observable type, this collection over time, and all the array functions that you know and love, plus a few more, actually. They've just implemented over observable. It's open source. It's been ported to C, C#, and VB.NET, JavaScript, and Netflix here has actually ported it to Java, and we use it extensively on the server. So observables are capable of modeling events, data requests, and animations. And because observables can model each of these three things and compose them together very easily, you can see how it can be very useful, a very useful building block for building UIs. Because what's UIs other than events, data requests, and animations? So it's easy to take any DOM event and convert it into an observable. It's just as simple as this. If I want to take the mouse move on a DOM event and convert it into an observable, I just call observable from event. Specify the name of that event. So you can see how if I wanted to subscribe to an event in the old style, I just call add event listener, I specify a handler, and then if I want to unsubscribe, I call remove event listener. Event subscriptions, or what I call the legacy way of dealing with events, the way I used to think about events. Sorry? We add an event listener, and then we remove an event listener when we're not interested in getting any more data from the producer. Well, observables allow you to do the exact same thing. I can for each over, and I get back this subscription object. And if I'm not interested in getting any more messages from the producer, I just dispose of that subscription object. So this by itself doesn't look too different from this, right? By itself, it's not too different. But by making a first-class object for events, we can use things like map, filter, and reduce, and merge, and zip, and a host of other methods to compose together complex asynchronous programs with very simple functions. So for each has got a few other tricks up its sleeve for observable. So I talked earlier about one of the challenges of async programming being error handling. So if you have an error that occurs anywhere within that observable expression, what happens is it gets propagated up, and you can handle it by providing a callback for dealing with the error to the for each method. And so that mouse drags observable that I created earlier, if it did something like went off to a network and got something, right, and could err, well, in my for each expression, I can just specify the handler. So what have we done here? Well, we've actually replicated the exact same conveniences that we have with try, catch, in synchronous coding. I don't have to check for errors at every single time I do a map or a filter. I can wait until I for each over that observable and check for errors right at the very top. And the last thing, the trick, the really big trick that Observable does that your typical events don't do, is they allow you to specify a callback that gets invoked when the observable collection finishes. And just by adding that simple notion of being able to stop, we'll see that you can actually approach async programming in a very, very different way. And so, once again, you can dispose of your subscription when you don't want to get any more messages anymore. So, this is not in JavaScript 6, but I'm going to make up a literal to help you guys understand exactly how Observable works and how it sort of fits together. So, not part of JavaScript 6, we're just going to pretend that this does exist in a fake JavaScript-like language, right? So, if I take for each, I can apply for each to an observable, and I get the exact same thing as if I did it over an array, except the only difference is it happens over time, right? So I get my results, right? Now, map, the exact same thing. I apply map to a collection, an event, and it applies a function to each item that comes out of that collection. And I get those translated values over time. Filter, I think you guys are starting to get the gist of it now, right? Same thing as arrays. We just get it over time. So all the skills that we learned over arrays can now be applied to events. And so concatAll, this is what it looks like for arrays. Now, one of the real challenges that we deal with when we do async coding is race conditions, right? And when you're working with async programming or you're subscribing up to events, really, unlike when you're doing synchronous programming and everything happens one after the other, if you subscribe to 3 events, really anything can happen all at the same time, right? And so it becomes very, very difficult to coordinate if you want to ensure that you process events in a certain order. But now that events can tell us when they're done, we can write concatAll, which we couldn't have written over events before. We can now write concatAll over events. So if I apply a concatAll to a collection of collections, an event of event streams, it looks something like this. Well, we have this observable that over time comes along with another observable, and we start listening to it. And we immediately get the value out. And then another observable comes along, and it fires 2. And we immediately flatten that and just push that value out. Now, while we're waiting for 3 to come along, another observable comes out. But instead of immediately just listening to that, I'm going to wait until this observable completes before I even start listening to this event stream. And this is how we control events to make sure that they happen or are processed in the order in which we want to process them. And so I just keep buffering. Another observable comes in. I still haven't gotten 3. I just buffer it up. I just hold on to that event stream, waiting to subscribe to it. Now, when the second one ends, we push 3 through. Then we start listening to this observable. We find that there's nothing inside. Now I want to point out, empty collections, when they're flattened, they just disappear. And this is very, very useful, and we'll see why in a moment. So we get no data out of this, and then finally we process 4, but we make sure that 4 appears after 3. And so just by adding that simple semantic to event streams, being able to say, I'm done, we can now implement concat over event streams. And so let's see what we can do. So earlier I promised you guys I was going to explain how TakeUntil works. It's actually really simple. We just listen to one event stream until another event stream fires. And then we just complete the overall event stream. So TakeUntil, just like map and filter, what we're doing is we're creating a new collection from other collections. So we're listening to a source of data, and we're listening to a stop collection. And whenever this source collection fires, we just push the data on through until finally the stop collection fires, and then we just complete the event. So why is it so useful to be able to complete an event stream, to have this notion of I'm done, beyond just concatAll? Anybody ever, I mentioned this earlier, anybody ever have an event subscription they forgot to unsubscribe and they leaked memory? That's kind of silly in some situations because there are some events that definitely end. Document on load, for example, is an example of an event that ends, but it's sort of like a friendly neighbor who borrows your keys to go get some beer, and then he brings you back the beer, and he just sort of stands there awkwardly with your keys, until you're like, can I have my keys back, That's really what document on load does. It holds on to your subscription, even though it knows it's already given you the message and it's done. By allowing observables or events to say, I'm done, you know what? They can just free your subscription at the same time. I haven't unsubscribed from an event in the last 5 years. I haven't. And my code's not littered with memory memory leaks, because I don't unsubscribe from events I complete them declaratively. I cancel events out. So if you're listening to an event stream, instead of registering with another event, and when that event fires, unsubscribing from the previous event, and then remembering to unsubscribe from that event, I just take those two events and I cancel them out. And that's why it's so powerful. And that's why we think about events very, very differently here at Netflix. We don't unsubscribe. We cancel events out. We declaratively describe the conditions under which that event stream is supposed to end. And then it cleans up for us. So let's take a look at our mouse drags collection. Now that we know how all these methods work, we should be able to understand this. It's relatively straightforward. We keep generating this new mouse moves collection every single time a mouse down happens, but we don't have to worry about unsubscribing from it because as soon as the mouse ups fires, we unsubscribe from both mouse moves and mouse ups. We never unsubscribe from mouse downs because somebody could start a drag operation at any given time, right? People understand this a little bit better now? They've seen how observable works? Okay. So let's talk about a more complex example, because I promised you observables are able to compose not just event streams, but asynchronous requests and animations. And when you put the three together, it's actually pretty cool. It's really breathtaking. So Netflix search is a great example of a surprisingly hard problem. Who's written an autocomplete box before? One of those problems that seems like it's going to be pretty easy, right? At first, you're like, I'll be out of here at 5, and it doesn't really turn out that way, right? So why is an autocomplete box so damn hard? It's because, right, well, the first problem, the first place where asynchrony enters the problem is if I type A, B, C, D, E, F, how many requests do I want to send off?
6.
Thanks, Mike. 1 request, right? I don't want to send off 6 requests back to back. And so we introduce a little asynchrony, or we debounce, as it's sometimes called. We want to wait, hang back a little bit, wait till things settle down before we send off a request. So we want to introduce asynchrony to make sure we've got a good user experience. The second problem is a much, much harder problem to solve, and it's very common in async programming. So let's say I type A, and then we wait our 20 milliseconds or 30 milliseconds, and then I type B. And so we've got a request outgoing for A, and now we've got a request outgoing for AB. Is there any guarantee my request for A is going to come back before my request for AB? No. It's a race condition. And so we can end up showing the results for A on top of the results for AB, right? And then you're there until 9 o'clock trying to figure out what's going on. So how do we solve this problem? Well, Observable, by creating an object on which we can hang off these methods that handle these common asynchronous patterns, we can solve this very, very easily. So I can take the key presses collection, because that's how I think about events. I think of them as collections now. I think of that collection, and I apply this simple throttle method. And all that does is it takes A, B, C, D, E, F, and it turns it into A, D, F. And then I map it. For every key, I call this getJSON method. And I go off and I get this observable, and that returns an observable. It returns a collection containing only one thing, which is an array of those search results. It's just going to be a collection that, after a little while, gives me an array of the search results. Now, this can fail, right? Every time we touch the network, we can have a failure. And so it could just be an intermittent network failure. So I wouldn't want to bring down the whole thing if we just have some small intermittent failure, right? And so I use the retry method. And what retry does is so simple. It just for eaches over an observable. And if it gets the error callback to for each, it increments a counter. For eaches over it again. If it gets an error again, increments a counter until it exhausts the retry count. And then it just forwards the error along. And so dealing with intermittent failures in the network is as simple as this. Then, what happens if I press, so I've got my outgoing request for A, right? It's going out, and then I press B. How do I make sure that that outgoing request for A doesn't return me anything? Because I don't care about it anymore, right? I just want the outgoing request for AB to return something. Well, once I create this request for A, it's in flight, it's an observable that's sort of dot, 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 dot. As soon as I press B, what happens? By applying TakeUntil to that outgoing request, I just complete the collection before it can ever return results. And now, at the end, when I flatten, what happens when you flatten an empty collection in another collection? Disappears. So I don't think about this as a state machine of rolling back states or canceling requests. I just complete a collection, and it's empty, and I flatten, and then it just goes away. And now the only thing outgoing is my second request for AB. At the end, I've taken the simple collections that I have in the system, and I've created more complex collections out of them. We do this all the time with functions. I have simple functions, I create more complex functions. For some reason, when we move to events, we don't think this way. I want to take small, simple events and I want to compose them into more complex events. That's what I've done here. I've taken something as simple as a key press and a function that returns a collection, and I've composed it into the event that I want, the high-level event, which is just a stream of all the search result sets I'm supposed to display. And then for each one of those search result sets, I just update the UI inside of my for each statement. And if an error comes, I say, hey, sorry, the server's down. And that's autocomplete with Rx. So we didn't stop with search. We've moved Rx to so many different parts of the Netflix app. And one of the ones I mentioned earlier was the player. Player, that callback hell that you saw earlier, we can do a lot better than this. If we recast, we think about, instead of just this series of operations that we perform, if we think about every single play as just a stream of, just a collection, we can approach this problem very, very differently. So really what we're after is when you start to try and play a movie, what Netflix will do is it'll go and try and authorize you, right? There's encryption and there's permissions, and so we need to make sure that you're authorized to play that movie. And so the very first thing we need to do before we do any of that is we need to make sure that the player is even initialized. We're working with a platform and that player comes up asynchronously, and so we need to wait for it to initialize. And that's as simple as listening for all the initializations in the initialization stream, which only ever contains one item in that collection, mapping over it, and then listening for all the attempts to play a movie. For each one of those movie attempts, those attempts to play a movie, we're going to call authorize on that movie ID. And that's going to go off and return an observable of a license. So an observable, just like the search result set, an observable that contains only one thing, and it's going to go ... and then give us a license. But in the meantime, what if they cancel? What if somebody cancels because they hit the back button or whatever else? Well, I just take that ... license and I complete it so that it's empty. And I never need to worry about canceling that outgoing request or worrying about it coming down at the wrong time. And then I take this two-dimensional collection, I flatten it, and so now we've just got a smooth stream of movie authorizations, of licenses for movies. And then I take this outer collection, because we're doing it for every initialization, of which there's only one, and then I flatten that. And we're left with just a stream of authorizations to play a movie. And all I do is to just traverse that stream, and I tell the player to play the license. And if an error happens, we say that we can't play it right now. So that's how we apply to player. So today we use observables everywhere. We use observables for really any part of our app that has any kind of async code in it. For coordinating all the things that are going on in app startup, for platform coming up, for metadata coming down, we use observables. For the player, we use observables. We use observables for our data access, not just on the client, but we actually use observables on the server as well. So our developers can transition very smoothly from writing Rx observable code on the client to then transition to the server and use the exact same concurrency model there. In fact, on the server, we create one big observable, and then we for each over it and push it out to the stream. And then on the client, we read it into an observable and just keep on mapping and filtering where we left off. So animations coordinated today with observables. So some of the demos you're going to see, really impressive demos of our animations moving from screen to screen, are all coordinated with observables. And view and model binding, ensuring that the view is updated when our model changes. That type of data binding is all done with observable as well. So here are some of the resources I want to share with you. The first is the link to the actual Reactive Extensions library. So if you're a JavaScript programmer, check this out. It's absolutely amazing stuff. The next is Rx Java. If you do any Java programming, this is Netflix's open source effort at porting Rx to Java. And the truth is, not only have we ported it, we're doing some really amazing new things. We're pushing the edges of what Rx can do right now. And we have an internal training program for teaching all of our developers Rx. And we've taught tons and tons of developers now to use Rx effectively. And so you can go to this address on GitHub and use the same learning exercises, this online interactive JavaScript learning exercises that we use here to teach our developers Rx. And that's about it, guys. Questions?